I have 8 examples of some of the concepts we've been talking about, and I'm going to try to go through them slowly and through the thought process that might help later on, as opposed to just maybe looking something up on a chart or something, but which you're welcome to do, but sometimes we need those thought processes as well. Okay, so we want to know what the cosine of 150 degrees is. So one thing we could do is we could draw it out. And 150 degrees would be over here, say, 150 degrees. We can calculate the reference angle, which is going to be like right here, this angle right here, which is going to be 30 degrees. So then I can think, well, what's the cosine of 30 degrees? Now, either I know what it is off the top of my head, or I could, one thing I could do, I could make a little triangle. Remember, it's 30 degrees, so that makes this 1/2, and I can figure out the other part. It's going to be the square root of 3. And then I remember the cosine is adjacent. Cosine theta is adjacent over hypotenuse. So then I say, okay, so it's going to be the cosine of 30 degrees is going to be the square root of 3 over 2. Now I have to think about, though, where the reference angle is, where the actual angle is. It's in the second quadrant, so then I have to think about x being negative. So it's actually going to be this negative value here, and so I'm going to get the cosine of 150 degrees is going to be negative square root 3 over 2. So those are all the different ideas we're thinking of as we go through that process. Now, some of these you're going to get used to them right off, and so that it might get easier to do. But let's look at another example. So this one I'm going to handle a little bit differently. Tangent of pi over 2. Pi over 2 is a quadrantal angle, so I can draw it out. It's going to be right here. I can think about being on the unit circle. The coordinates for that point are 0, 1. So that's where pi over 2 is. Pi over 2. Okay. So then I think about tangent. Well, what's tangent? Tangent is opposite over adjacent. Well, that might not really help me very much. It might be easier for me to think of y over x. I think we did that when we were doing the basic ones. So now I can think, well, the tangent of pi over 2 is going to be that y value 1 over 0, which is undefined. Another way I could think about it is to think about the graph, and having an asymptote at pi over 2 would make it undefined. So all kinds of ways to look at it. All right, let's keep going. All right, this one's a little bit trickier. So we have a negative 13 pi over 3. So we've got to think about what that means. What does that mean? Okay, so it's negative, right? So I'm headed off in the clockwise direction. And what's a full circle? A full circle is 2 pi. Okay, but 2 pi, I want this in thirds, so I'm going to say it's 6 pi over 3, right? So if I went one time around, that would be 6 pi over 3. I'm going in the negative direction. Then I'd have to go another time around. Another time around. That'd be 12. Now I'm at negative 12 pi over 3. So I'm at negative 12 pi over 3. And I want to go negative 13 pi over 3. So I need to go a little bit more. So I need to go another negative pi over 3. So right there, I'll kind of connect it up very well, but anyway, it was 2 times around, and then I had a negative pi over 3. Well, what's the reference angle? Pi over 3 is the reference angle. If you're thinking about going to the x-axis, so my reference angle is pi over 3. I am in the 4th quadrant. I might need to know that. So I haven't even looked at what function we're doing. We're doing sine. Okay. So now I want to know the sine of pi over 3. And then I'm going to think about being in the fourth quadrant in a minute. Okay, sine of pi over 3. Let's see, that's 60 degrees. So I know the cosine of 60 degrees is 1/2. So the sine of pi over 3 is going to be the square root of 3 over 2. And I can go through that. I can use triangles. I can use a unit circle. And then, so now I know the sine of my reference angle, but I'm in the fourth quadrant, and I have to think, well, is the sine negative in the fourth quadrant? Yes, the sine's negative. So sine is negative in the fourth quadrant. So all of the functions, they're positive in 2 quadrants and negative in 2 quadrants. And sine is negative in the fourth quadrant. Think about it being the y value, and so it's down. Okay, so the sine, put this all together now, of negative 13 pi over 3. And you might say, well, why don't you care about the coterminal angle? We did do a coterminal angle, but we're not listing our answer that way. Negative 13 pi over 3 is not the same angle as negative pi over 3. They're just coterminal. And because they're coterminal, they're going to have the same sine value. So this is going to be negative square root 3 over 2. And let's see if we can get one more in. Okay, so it's a similar idea. Secant, 910 degrees. So we're going to think about the degrees. And you could go around again, you know, it's positive. So here's 360 degrees. Here's 720 degrees. Let's see what that is. 910 minus 720. They talk about this in different sports. Let's see, I think I'm getting 190 degrees. Check my math. Okay, so 190 degrees, I need to go 180, and then I need to go a little bit more, right? So I'm getting it right here, and that's going to have a reference angle then. Let's see. The reference angle right here, my reference angle is 10 degrees. And I want to know the secant of that, right? I think I know why I picked this problem. So the secant of 10 degrees. This is not a special angle. So I have to grab my calculator. And if I want a decimal approximation, so what I'm going to do, my calculator doesn't have a secant button, so I'm going to change it to 1 over cosine 10 degrees. Make sure I'm in degree mode, which I'm not, so I've got to change it to my mode here, degrees. Okay, so now I'm in degree mode, and I'm going to go 1 divided by cosine of 10. And I get 1 point, so it's approximately 1.0154. I'll just leave it at that approximation. So sometimes we have to do that. We have to get a decimal approximation. And if it's a secant, you don't have a secant button, so you'll have to use your 1 over cosine idea. And then just make sure if you're in degrees, you put it in your angle in degrees and put your calculator in degree mode. Okay.